Okay, I hope you've had a chance to review the first part of this video, and I hope you understand the need now really to latch that signal that is coming from somebody who presses a button to actually cross the road. Now we're going to look at what is inside this SR latch. Now here is one approach. We're going to look at two NOR gates here. Okay, we've got an input here, an input here. Now you'll notice from this NOR gate, this output is actually connected back really to the input of this lower NOR gate. And then if you look at the output of this NOR gate, it's connected back to be the input of the one on top. All right, now look, since we're going to try to analyze really this circuit here, it's not a bad idea really to put down the truth table for a NOR gate. It really helps us to think about the problem. So let's go ahead and do that over here. All right, so we'll look at two inputs, 0, 0, okay, and we'll be looking at the output of the NOR gate. So a 0, 0 into a NOR gate gives me a 1 for the output. If I have a 0, 1 for the inputs, then the output would be a 0 for that particular NOR gate, and then a 1, 0, the output would be a 0, and then 1, 1, the output would be a 0. So that is the NOR function, okay? Now we'll use that to help us understand really what is going on here. Now when you look at a circuit such as this, you think, well, you know, where's the starting point? Well, I have to tell you, it's a very symmetrical circuit, isn't it? I mean, if you flipped it up the other way, you really couldn't tell the difference, could you? No. So look, what I would do as a starting point here is I'd put both of these inputs at 0. So both of those inputs are tied to 0, okay? Now, what next? Well, I need to choose basically one of these outputs here to be Q, and the other one Q bar. I need to choose a value for Q, okay? Does it matter which one I choose? No, it really doesn't matter which one you choose, okay? Having chosen one, it may dictate, of course, which one of these inputs is S, which one of these inputs is R. It certainly will have an effect on that. But as a starting point, I could choose either one of these guys as being Q. Now, so I'm going to choose, let's say this one over here, I'm going to choose that to be, let's say, Q. All right, and I'm going to choose my starting point here for Q being a 0. Okay, so Q is sitting at a 0. That's my starting point. Now let's look at this, okay? If this Q is a 0, let's look at this. This is fed back, isn't it, to the input of this gate sitting over here. So what have I got here? I've got a 0 sitting here. Look at that. Fed back like so. I've got a 0 sitting here. I've now got a 0, 0 to this NOR gate. 0, 0 input to a NOR gate gives me what? Look at the truth table. 0, 0 as an input gives me a 1. So really this is sitting at a 1. This output over here is sitting at a 1. Now look, this 1 is what? Fed back like so to the input of the lower NOR gate here. So we'll reflect that like so. So the 1 sitting there. Now let's look at this. I've got a 1 sitting here. I've got a 0 sitting here. What's the output? Yes, it's a 0. 1, 0, output being a 0. No problems there. All right. Okay, so that's a setup. That's my initial state, if you like, or condition, if you like. Now, which one of these guys is going to be the set line? Okay, now let's think about that. Supposing I choose this one here, okay, for a moment. Supposing I make this a 1. Is it going to change the output? If this becomes a 1, then I've got a 1, 1 feeding into this NOR gate. 1, 1 feeding into the NOR gate. 1, 1 gives me a 0 output. So there's no change there. So basically by making this input go to a 1, I've changed nothing here at all, okay? So this cannot be my set line. So really my set line, or S input, is really this guy over here. That is S. And then this one, of course, is R. But now let's look at that for a second, all right? Supposing I now make S go to a 1. What's going to happen? If S goes to a 1, I've now got a 1 and a 0 as an input to this NOR gate. S has gone to a 1, 1 and 0, input to this NOR over here. Well, a 1 and a 0 is going to cause the output to go to a 0. So really, I'm going to see this output now changing. That output will go to a 0. So there it is going to a 0. Now that 0 then is what? It is fed back, isn't it, to the input of this NOR gate. So really this 1 changes and becomes a 0 sitting here. I now have a 0, 0 at the input of this NOR gate. What's the output? 0, 0 at the input of this NOR gate. Let's look. 0, 0, output goes to a 1. And so really the Q value now goes to a 1. Basically what I've done now is I've set or latched in this condition here. I set the SR latch to a 1 condition. Okay? Alright, so basically having now set the Q output to be a 1, now that's the case where what? I had S going to a 1 which caused this to happen. Alright? Now supposing I basically now remove S, or I make this S input go back down to a 0. This is like what? Pressing the button. S goes to a 1, then back down to a 0. So let's look at that. So now I'm going to change S. I'm going to bring S back to a 0. What's going to happen? Alright, let's think about that. If this has gone to a 0, I have a 0, 1 as an input to the NOR. A 0, 1 means basically this output, 0, 1 as inputs here, this output does what? Here we go, 0, 1. What happens to the output? Doesn't change, does it? Doesn't change. So that's exactly what you wanted. That output doesn't change, means that this doesn't change here, means that this doesn't change. So with S going back basically to a 0 here, we get no change in the outputs. Okay, no change in those outputs. All right? Okay, so what I'm doing now is reflecting that condition where we've got our Q. Remember, this is Q. We've got our Q now basically set to a 1. Both of these inputs now are sitting at 0. Okay, so this output did not change. All right? Now, supposing now what I do is I make reset go to a 1. Reset go to a 1. So let's do that. So that is making this R input here go to a 1. What's going to happen now? Let's think about this. I've got a 0 here, a 1 here. A 0, 1 causes the output of this gate to do what? To go to a 0. So I now see that output really going to a 0. Okay, that 0 is fed back to be the input to this NOR gate. So I see this 1 changing to a 0 as a result of this. I now have a 0, 0 as an input to the NOR gate here. 0, 0 gives me a 1 output. So there we go. This becomes a 1. This 1 is then fed back, and so this now is a 1 sitting here. So here I have then basically the R going to a 1. It has basically caused this output Q to basically go back to a 0. We can say that this is what? A resetting condition. Okay, a resetting condition. All right? All right, so here we are again. All right, this is our reflected new condition. We've reset Q. Here is that R that caused that to happen. Now look, what I'd like you to do is maybe stop at this point. And look, take R back down to 0 again, okay? So once again, if I take R to 0, what's going to happen to these outputs over here? Well, look at this. It's not very hard. I've got a 1 sitting here as one of the inputs. If this input were go to a 0, that is what? Taking R to a 0. What have you got here? You've got a 1 and a 0. 1 and a 0 means this output is still a 0, isn't it? So the outputs wouldn't change. So if R went back to a 0, the outputs would not change. Okay? Now, you remember I said to you that the 1, 1 condition here is not allowed if you want this to function properly. All right? Now, let's just for a moment look at what might happen. I've got R sitting at a 1 here, but what would happen now if I raise this S to a 1? Let's look at that. Okay, so here we go. We're going to just raise this S to a 1 here. Now we're holding R at a 1 as well, which we shouldn't do. It's not going to operate properly if we do this. We're just exploring what might happen. So here is that R. It has gone to a 1. I'm sorry, here is that S, which has gone to a 1. R is a 1 as well. Let's look at this. A 1 and a 0 going into this NOR gate over here. 1 and a 0 causes that output to do what? Causes the output really to go to a 0, doesn't it? So the output has gone to a 0. that zero's fed back over here, isn't it? So here is that 0 fed back, and to this NOR gate over here, what's going on? I got a 0 and a 1 sitting here. Okay, 0 and a 1, so that's still staying at a 0. So look, if R was maintained as a 1, I think I might be setting Q, but I don't set Q. Q does what? Q stays at a 0. So this latch will not set under these conditions, okay? And so really what we have to say then is that, look, S equal 1, R equals a 1, we're going to say that, look, that is not allowed if you want this SR latch to operate properly, okay? And so we just quickly explored that situation. Okay, that was the case where we built our SR latch really with NOR gates. These are called cross-coupled NOR gates, and we analyzed how that worked. Now, we could use an alternative approach, okay? So let's look at this. All right, now for a moment, let's once again draw the NOR gate. Here is our NOR gate, all right? And let's supposing for a moment we said I had inputs A and B. There's our output Y. Well, what is the expression for Y? Yeah, Y is A or B, isn't it? Bar over the whole thing. That's the NOR function, isn't it? What if I applied De Morgan's theorem on this? What would this be? Yes, that would be what? A bar, B bar, okay? A bar, B bar. So look, what does this look like by way of a gate? If I wanted to implement this with a gate, what does it actually look like here? Yeah, basically it looks like what? It looks like an AND gate, doesn't it? With what? Inverted inputs, like so and like so. So there's Y, this would be A, this would be B, and we would say that these two gates are what? These two gates are equivalent. These two gates are equivalent. Okay? Now what I'd like you to do is the following. Alright, there's our SR latch built with these cross-coupled NOR gates, okay? We've shown here what? We've shown that the NOR function, the NOR gate, has an equivalent being what? Being an AND with inverted inputs. So what I'd like you to do, this is going to end really part 2. What I'd like you to do is, how about replacing this and this with this gate here and redrawing the circuit? And then look, see if you can work with that to see how you might go from something that looks like this to something that looks like NAND. Have a look at that and see if you can try that as an exercise, a problem, before you really start part 3, and then we'll sort of do that in part 3. Okay?